Hello students, our tutorial and activity discuss our integral equations and boundary value problem, very important topic in mathematics. So must subscribe to this channel, get all these videos on this topic and share with your friends, and comment me. If you like this video, then click like and comment me. So let's start. I now first introduce about what is integral equation and what is boundary value problem. Let's start. First, I introduce the preliminary concept that preliminary concept concept is that first to formulate integral equation, Abel have a Abel's problem is the best to know about the integral equation how it is formulated. So I first provide discuss about Abel's problem. Abel's problems for Abel's problem to discuss Abel's problem you need a diagram. So I'm sketching a diagram. This is the diagram. Here it is. Will take in reverse a rotation of uh, anti-clockwise rotation. This is 0 and just will take this is x-axis and this is y-axis. So here you are getting looking that this is the vertical problem, this is the horizontal one. So here x-axis is the vertical by rotation, y-axis is the horizontal. So now we will take a point is moving through a curve in this way and touching the origin and goes through the second quadrant. Here we leave that this is a point P and its coordinate is xy. So this point moves under gravity, under gravitational gravity, under gravity G, gravitational force. So if it hit on the vertical point, then it slides under the gravitational motion and it will come at the point Q and then its coordinates are, I am taking eta, xi eta. Now I take that this distance is from the origin to the from the origin to the point Q, the distance, the curve distance actually is. Then you draw perpendicular on y-axis, not y-axis, but on x-axis. So this is actually x. This distance is x, and this distance is y. So this distance will be y x minus z. This distance will be x minus z. Now the velocity at the point q, if we know through preliminary knowledge that v square is equal to v square is equal to u square minus 2gs. Minus 2gs. This is the first, it is under the gravity motion. So this is 2g, and here the distance will be what? X minus j. Horizontal distance x minus j. So 2gs. This is the distance it down at under gravity. This is the distance. This distance under gravity, the point particle moves down. So here v square can be written as ds by dt, and the distance at the um, the distance made by the point q from the origin. So it is it in this way this is positive. If you take in this direction this is positive, and in the reverse direction this is negative. So from the origin we are measuring, and the distance is from the origin, so it will be negative. So the v is equal to ds by dt here, so it is negative actually. So I will begin this way, and u the primary is the initial speed is 0. This will be 0, and here I am giving the negative side. Negative side just shows that the motion is against the velocity is measured against the direction of the motion. So I am measuring velocity in the reverse direction of the motion. That's why I am taking negative. Now here it will this will, the negative will come later. First we will get this d square by dt, ds by dt square by 2g by 2a g x minus j. Then ds by dt will be ds by dt will be, which is the velocity v at the point q, is root over 2g x minus j. Now the velocity is taken in the reverse direction of the motion is falling. So that's why we will take a negative sign, just to show that the velocity measured from the origin, and it is reverse of the direction of the point falling on the through the curve. So this is, now it can be further written dt is equal to ds by ds by minus root over g by 2g x minus integrate it from q to p because I have taken negative side and I'm measuring the velocity from the origin. So I will take the integration sign from q to p, then it will be t equal to integration q to p ds by minus 2 power 2 x minus z. Now, if we change the limits, upper limit and lower limit, then the minus will not be further. We can um, keep the negative side, that rearranging the limits, lower limit, upper limit. This will be in this part ds by root over 2g x minus z. Now, one point that if if we take that ds with respect to the x-axis, writing in this way, ds by dx with a function xi uh, means that any tangent with respect to the x-axis on the uh, curve will be uj. Then it can be ds can be changed by in this way, integration p u uj. This is I'm changing variable xi because xi is actually changing, not x changing. The point xi continue if q point is moving, p is at the point of the initial point, and q is moving to the curve. So xi is changing. So ds by dxi, xi into dxi root over 2g minus z. So here actually this is the Abel's problem. Here we have to find out if we'll take this function uh, of x function, that time time is a function of x, then this function will be changed by just in this way. I'm just changing this. It will be changed by if time is t is a function of time is a function of x. This will be in this way changed. This lower limit will be 0, and the upper limit will be x. This is the x point, and the others will be kept same. is now the function of x. In this way, Abel's problem can be formulated. Here, to evaluate the uh, value of the, we need to find out the value of u. This will so here the question of integral equations arise. How integral equation can be solved? So you know different kind of integral equation. But first we know what is the integral equation. Integral equation is such kind. Take an example. Uh, this is yx minus lambda integration e to b to b. I give an example of the integral equation. This is called kernel of the integration equation a x t y t dt equal to fx. So here the integral equation is defined that uh, any function, unknown function, this is the unknown function, if comes under another functions which are under integral equations, maybe or not. So here it is it comes a non-integral function. It is a integral function. So the unknown function comes under this non-integral functions, and it is just a non-simple function. So one and more integral functions can be. So a unknown function can be under a non one or more unknown integral equation. Then this is called the integral equation. So here y is unknown function, and this is the non-integral function here, and fx is also the integral function. So now you know it can be in the common form, the most general linear form of integral equation. Linear form of integral equation is that linear form of integral equation. Most common uh, integral equation form, linear form of integral equation, most general, it is that gx yx is equal to fx plus lambda integration. Upper limit we will not provide. Upper limit will be constant or a variable. So upper limit is a question mark. There is a question mark. It will be two types depending on the upper limit. So I am not writing here. I will later discuss this. The kernel of the integral equation, and this is yt. Here first condition arises that may be if it is any integral equation is in this form, then it is of third type. It is called third type. Third type of integral equation. Type of integral equation. Now, if here is a here the upper limit is constant, then this will be Fredholm uh, Fredholm integral equation of third type. And if there is the upper limit is a constant, a variable, then this will be Volterra type of Volterra integral equation of third type. So depending on the upper limit of the this integration, this is a constant or this is a variable. If this is called a constant, I have said this is called Fred Fred Hom integral of third type, and if this is a variable, then it is called Volterra Volterra integration of third type. It can be the second case, maybe that dx is equal to 0. If dx is equal to 0, then the equation just remains that this term is equal to 0. Then if this term is equal to 0, then it will be first type. It will be first type of integral equation. And again, depending on the upper limit, if it is a constant, then we will call this is a Fredholm integral equation of first type. If it is a variable x, then we will call this is a Volterra type of Volterra integral equation of first type. Now, it may be that gx is equal to 1. The third type is that maybe gx is equal to 1. If we put gx is equal to 1, then we will get second type of integration. Second type. So here also again, depending on the upper limit, if the upper limit is constant, then it will be Fredholm integral equation of second type, and if it is a variable, then x, then it will be called Volterra integral equation of second type. So depending on the cases of the form, Volterra type of integral equation and Fredholm type of integral equation are defined in integral equation. So I hope the introduction of integral equation you have liked. I will later discuss the solution of such kind of integral equations and also any boundary problems. So keep watching these videos and subscribe this channel to get these videos. Subscribe this channel, share it to your friends, comment me, and if you like, then like these videos. Thank you.